In this video, we will talk about finding inverse functions and sketching their graphs. So I want to do an example where we find the inverse of f of x, and then we sketch f of x, the original function, and the inverse function. So in class, we did part A here, involving this cubic function. So the example I want to do now is part B. So in B, we have the function f of x equals square root of x plus 1. I want to find the inverse and then sketch the graph of the original function and the inverse. So to get this started, I have to do a few things. I have to sketch this original function. I have to find its inverse. Let me start off by sketching the original function. So the parent function for this is y equals square root of x. So if we draw some axes, and remember the square root of x graph, that's the one that's got this initial point at the origin, and then it curves upwards like this. Okay, so my square root of x function. So now, when I look at my function with this plus 1, this is going to be a practice problem in terms of shifting and reflecting. So if I look at y equals square root of x plus 1, and I draw some axes, well, that plus 1 is going to shift. It shifts our graph up 1 unit. So it's going to shift it up by 1. So this initial point is now raised 1 unit up. So it's going to be at 0, 1, and then I get that same square root of x shape. Okay, so that is the graph of my original function. And just for reference, let me write down the domain and the range. Because remember, when I go to the inverse function, that domain and that range will get swapped. So the domain of this is all the x values, and the x values start at 0, bracket, because 0 is included, and then it goes onwards to infinity. And for the range, those are my y values, and the smallest y value here is 1. And I put a bracket because 1 is included in the range, and the y values go onwards to infinity. Okay, so that's my domain and that's my range. Okay, so let me highlight these. This is domain, this is range. So now let's get our inverse. So let's get the inverse function. So remember, the first step in doing that is we swap the x and the y. So in our equation right now, it's y equals square root of x plus 1. If I swap the x and the y, we'll get x equals square root of y plus 1. And then we try to isolate the y. So we could subtract 1. We get x minus 1 equals square root of y. And now to get rid of the square root, I would square both sides. And I get x minus 1, that quantity squared, equals y. Okay, so at first glance, we get this. So it turns out there will be a problem with letting this be the inverse. So let's look at the graph of this to figure out why. So y equals x minus 1 squared. If I draw some axes, well, this is a quadratic, and it's already in vertex form. The vertex of this is going to be a 1 for the x-coordinate, comma 0. Okay, 1, 0, and it's an upward-facing parabola because the leading coefficient is positive here. So an upward-facing parabola. So my parabola looks something like this. So the issue with this is, for a function to have an inverse, and for this to be the inverse function, it needs to pass the horizontal line test. But this doesn't. So the way I need to adjust this now is I need to go back and remember my domain and range of the original. Because for the inverse, those are supposed to be swapped. So my domain here is actually supposed to be the range of the original function. So it's supposed to be 1 to infinity, the range of the original. Okay, and if I were to write the range of this inverse function, the range is supposed to be the domain of the original. So 0 to infinity. Let me highlight that in green. So my actual inverse function, f inverse of x, it's going to be this formula, x minus 1 squared, except the domain is limited. It is restricted. The domain is restricted to x values that are greater than or equal to 1. That's my domain. So if I draw some axes and draw this actual graph, Because x is greater than or equal to 1, that's only the part of the parabola on the right here, this right half of it. Starting at that vertex at 1, 0, it's just the right half because those contain the points where x is greater than or equal to 1. Okay, so this is the sketch of my inverse function. So one of the key takeaways from this is that with the original function graph and the graph of the inverse function, they need to both satisfy the horizontal line test. So if I get my inverse function and I sketch its graph and it doesn't satisfy the horizontal line test, then I typically need to think about the domain and the range of the original and make sure that for my inverse, I swap them. And that can help me identify, well, which part of that graph am I actually looking at when I construct the inverse? The other key takeaway looking at these two graphs is, remember, the original graph and the graph of the inverse are supposed to be reflections of each other across the diagonal line y equals x. And looking at these two graphs, they do seem to be reflections of each other across that diagonal line.